rather than, because I knew that if I didn't respond, so I'm guessing. Just say that.
Yeah, whatever that might be. Content, but I at least have remembered saying something.
Yeah, indeed, I remember that.
Just ask whether I want to something. I'm like, oh, it's just like
We also have already.
Did you just say maybe a couple of slices? I think maybe meant maybe a slice. No, maybe a couple of slices.
Are you LinkedIn?
Hey?
LinkedIn? Are you LinkedIn?
Yeah.
Your name and my network? Yeah.
It's Mark.
M-A-R-K
Knut.
K-A-N.
K-N.
Oh,
Knut.
I know. Which one? The first one. Having the. Yes. Thank you.
Yes. Yeah, sure. Oh, yeah. What's your name?
You have my name.
Oh, okay, yeah. Yeah, okay. Nice to meet you.
Yes.
Thank you.
So much.
There's loads of most of the company.
Oh, there's a little setup. Bam, deal. You know, we're going at it. Okay, yeah.
Yep, everything's all ready.
Because I always.
Actually, you want one. Yeah, no, you only need to do it and then if I go away, I'll say that. That doesn't mean you can do it. You know what I mean? Yeah, that
Freeze away.
Have you another fan?
Of course I have.
No one's sensible will buy the fan. Oh, hang on, it's not on rotating. Oh, it is.
Thank you.
Just so really used to work with this.
I went.
Does someone else use playground? They try to. Yeah.
Yeah.
Yeah. She loves
That's the second time.
Yeah.
On me. Come on.
Sorry about that.
Yeah.
I've got a membership. Once a month.
Who does that?
Do memberships. All of that is £79.
I don't mind. Yes.
Oh, yeah, go for it. I want to get people in. Yeah, yeah, absolutely. Hey, folks, we're starting in 5 minutes. Grab some food and come in. Yeah, yeah. I like it. I have no use currently, so that's very. Oh, really? Yeah. I was like, I could shout over this, but I don't have that kind of voice. Yeah, I love that.
Another beer if I do, I'll fall asleep.
Huh.
It has that effect on me. When I was younger and drunk.
There are non-alcoholic things.
There are. Maybe you later.
Okay. Should you start phoning in? Nice kind of thing. Why is this one very short?
Oh, sorry. I can actually grab one because I didn't actually grab it. Oh, yeah. There's a freezer.
Yeah, another. I was like, I don't think I'm gonna be able to shout over everyone. I think people heard the bell, so try that.
Everyone, the first call's about to start. Please grab your seats.
I think that picture is inverted.
Which picture?
The one right there. Check out the London Eye, Houses of Parliament.
Might be right. I have a feeling I stole this picture from somewhere online about 5 years ago.
Right.
And I may have inverted it so it looks better in this. But you might, I think you're probably the first person to have noticed it in 5 years.
I need to get a life.
No, it just means that you know the skyline people. I have to.
You're in a lecture, you don't want to sit.
No, but in terms of leg space.
Would you like me to move forward? So looking at this picture, is like,
It's the general.
I think everyone shuffle back a little bit, so we're okay.
Yeah.
Yeah, exactly. Yeah, now they're gonna really struggle. Yes, I have the shortest legs. I never complain in the airplanes. Never had issues. It's good luck.
Maybe I'll try and find the original picture and see if I did actually invert it. Yeah.
What inverts it?
At this point, this will show up with the cloud native London stuff on it. Come in, come in, come in. There's loads of seats.
Oh, yeah.
I mean, no need to stand at the back. There's a whole chunk of seats here. Well, I mean, there's like 6 seats probably in the front, so that's nice. Okay, we're about 7. Welcome to Cloud Native London, everybody. I'm going to do a quick introduction before we go into the results for this evening. Sweet on. All right, so who are we? We are a strong, open, diverse developer community around the cloud native technologies and platforms in London. A quick little reminder, as from last time, please be courteous of this office, which is being hosted by our friends from esynergy. I think last time there was like garlic sauce dripping down the air conditioning vents. People would eat pizza and then put it back in the box. So it's kind of gross. Just like clean up after yourself a little bit. Thank you. My name is Cheryl. You can find me on Twitter or Cheryl. I'm currently at Apple, working on Apple Cloud Services, but most people know me from my time at CNCF. So we've got 2 talks for you this evening. The first one is how a team with no previous DevOps experience took a monolithic legacy Java application from Tomcat to Kubernetes. And then we'll have the second talk on testing and validating container images with Container Canary. We did have a third speaker for this evening, but unfortunately they contracted COVID, so we've only got 2. So thank you to tonight's sponsors. So first up, I think, you want to say a couple of words?
Hi, everyone. So yes, we are esynergy. Very proud to be hosting the Cloud Native London meetup. So for anyone that doesn't know us, esynergy are a tech consultancy, and we specialize in building products, platforms, and services for a range of clients, mainly enterprises, scale-ups, tend to focusing in highly regulated industries. So some of those clients you may know, HMRC, Marsh, and Wayfair, across the board, a number of different clients there. So yes, without further ado, I will hand over to our wonderful associate, David Oliver. Oh no, we've got one more thing. I was too, that's how much I'm, keen to introduce David Oliver. But yes, so without that, I will hand it back over. Smooth. I was like,
okay, so the other 3 sponsors cannot join us for this evening, so I'm going to read a couple of words on their behalf. So first up, we have CircleCI. The world's best software teams use CircleCI to deliver quality code with confidence. As the largest CI/CD platform, CircleCI empowers engineers to seamlessly take ideas to execution at scale. Every feature of their platform is built to fine-tune the entire development process from start to finish. And then we have Palo Alto Networks. Palo Alto Networks enables your team to prevent successful cyber attacks with an automated approach that delivers consistent security across cloud, network, and mobile. And then lastly, we have Sysdig. Sysdig is driving the standard for cloud and container security. With Sysdig, you can prioritize software vulnerabilities, detect and respond to threats, and manage cloud configurations, permissions, and compliance. Your teams get a single view of risk from source to run with no blind spots, no noise, and no black boxes. So I want to say thank you to all of our sponsors, mainly for providing pizza and drinks and the like, but mainly honestly, they managed to really keep this meetup running. So we do want to say a proper thank you to them. All right, so we're going to do a little bit of polling. Find out a little bit about you. So please grab your phone, laptop, whatever, and go to this link, oyshow.com/e. That's going to redirect you to a service called Poll Everywhere. And you don't need to sign in or anything. I'm just going to ask a couple of questions about you and a couple of questions about how you use cloud native. The first question is this your first time at Cloud Native London? So yep, you should see a yes and a no, and just hit yes or no. If you lost that link, there's a long one up here, that's pollev.com/Cheryl. So watching these results come in, I thought the yeses came in strong, but the no's seem to be pulling ahead just slightly. Still getting over 60% no's. Give people a few more seconds to figure this out. We also have people joining live on YouTube and on Twitch. So I'll give them a few seconds to figure this out as well. Looks like the no's are edging ahead. Okay, let's give a few more seconds. Okay, a couple of first timers coming in. Well, either way, thank you. Really appreciate it that whether you're first time or whether you come back. Oh, pretty 50-50 now. Okay, interesting. Second question, what is your job title? So pick the closest answer. Options are architect, application developer, backend developer, engineering manager, SRE/DevOps engineer, security engineer, or anything else. Looks like people really got the idea now. Backend developers pulling. It's architect, application developer, backend developer, SRE, and other all seem to be probably around 26%. If you chose other, want to mention what you do? The one that chose other.
So what I do?
Yeah.
CTO.
Okay. Sweet. No security engineers amongst us today. Everyone else very even. This might be the first time I've seen it. Seen it even actually. Nice. All right, let's go on to a couple of questions about how you run cloud native or how you run Kubernetes. If you were an application development team, would you prefer to manage your own Kubernetes infrastructure or use a platform managed by the wider organization? So David submitted this question. So as the results come in, I'm kind of interested to think is this what you were expecting results-wise, or?
No, it's not what I was expecting, but yeah, interesting.
So you were expecting more people to want to manage their own Kubernetes infrastructure. Interesting. Well, remember, this is from the point of view from the application developer team. So this is not asking, do you want to run your own versus use AWS, right? This is if you're an application developer, would you prefer to do it yourself or have another team do it? Okay, wow, it's pretty heavily on the use something managed by other people. Nice. Okay. Next question. So how many applications are you running in your Kubernetes cluster? So anywhere from 0 to 200 plus. Yeah.
It's very interesting.
How many applications? Okay. I feel like this might be a bit difficult to define. Okay, still good quarter of people saying nothing, nothing at all. Perhaps they're not running Kubernetes, or it's been an option. Really wild people paying over 200 plus. Okay, so this was submitted by a second speaker who unfortunately is not here because he has COVID. I think this is probably what I would have guessed as well, actually. Okay. The third one was submitted by Jacob, who I believe is now on the line. So question, do you write tests for your container images? Yes, no, or how do I do that? Okay, so people going, how do I do that? 52%. Okay, so Jacob, are you there? Can you hear us?
Yeah, I'm here.
Excellent, Jacob. So what were you thinking when you submitted this question? This is what you expected?
I mean, that was kind of roughly what I expected, to be honest. I mean, my talk is going to be about writing tests for container images, so I feel like I'm speaking to the right room. So that's great.
Well, you're 17% who either like don't write tests and think they should, or are against tests. So I'll be interested to see how that breaks down. But yeah, it sounds like 50% of people want to hear about how you write tests for container images. So that is awesome.
Sounds good.
Awesome. Thank you, Jacob and David. And thank you to all of you for playing along and submitting your answers. Selfie time. So this is everyone's just going to smile and wave for me. All right, just big hands, big smiles. Nice. Thank you. And then if you want to come and speak or you want to come and sponsor Cloud Native London, go to cloudnativelund.com. It's got all the information. You can sign up there. The next speaking slot is in 2023. So sign up early if you want to come and speak. And that is it. So I'm going to hand over to David now. Stop the sharing from here. And David, the floor is all yours.
Perfect, thanks, Cheryl. Excellent. So yeah, this is going to be a bit of a kind of case study, reliving some dark days last year. And it's really about what happens with a team who haven't encountered DevOps. They think it's a person who cleans up after them. Have to take a big old-fashioned Java app and move it to Kubernetes. Well, can we get this to work? So yeah, just a bit of background about me. I'm a long-time Java developer. Love Agile because it helps get things done. Tried all kinds of funky tech solutions to get around problems and discovered that people keep getting in the way. And so that's me. Just so you know, this comes from that kind of dev team background. How did dev teams see the world? And this is pretty much what we're going to go through. I'm going to tell you a little bit about the project, how it ended up happening. Some things I learned about what happens when a Kubernetes transformation is kind of lumped on a team versus when a team discover Kubernetes for themselves and decide to migrate that way. Take you through the journey that we went through. Talk a little bit about how we're living with the live system and a few of the lessons that we learned along the way. So, the story kind of starts a little bit into a consultancy engagement. The original kind of brief for the team was to come in, work with this engineering team and help them kind of adopt some best practices. The kind of team, they had a really long release cycle, didn't really do very much testing, didn't really get very much done. So they asked us to come along and help. We worked on a small project, delivered that successfully. And as a result of that success on that part of the project, they were like, great. Now we've got this workflow system, kind of helps insurance companies, like basically broker, like complex insurance products for commercial organizations. We've got this, automates loads of things, makes it a lot easier. We want to roll it out to another 15 countries. So we started doing the work to get to this, and then we had the big bombshell. We were happily deploying things to our Tomcat servers. We asked for some more space on the app servers, and we were told, very sorry, our app servers are full, and actually our boss's boss has told us no more app servers ever. Everyone's going to Kubernetes now. So this was a bit of a problem to that initial project, but as we had to do it 15 times, I was pretty keen on, yeah, let's just go with this. I'd worked on a couple of Kubernetes migrations before, so I thought this is going to be easy. It's going to save us all kinds of problems. Let's go for it. So this is a little bit of a kind of context we were working in. We were actually kind of working in a bit of a wider team. There's a team that I was looking at after, was like looking at kind of global projects, and we were really looking at this rollouts to new countries. We were working in Scrum and kind of introducing agile ways of working to the organization that way. And we were kind of paired with this big UK team, had a massive backlog of business features. They weren't very interested in our agile ways in our new countries. They had plenty enough of their own kind of day-to-day problems. So everything we did, we had to try and keep the UK team kind of coming with us, but not getting in the way. The UK implementation was massive and delivering such big value to the business that we couldn't really disturb them. But at the same time, the kind of organization was saying, yeah, if we roll this out to all these other places, there's great things to happen there. So that's kind of, yeah, stuck in the middle, kind of guided some of the decisions that we had to make as well. And I think looking back on the project, this is the first thing that I realized. Like when somebody asks you, well, we've got this problem, can you solve it this way? The first thing I started doing was thinking about how we could all do it. Yeah, a year later, in hindsight, it's like, okay, maybe should we have done it? And as we go through this, we'll kind of see why we shouldn't, or at least I can see from the business point of view why we should have. But I think we would have had a much smoother project journey if we'd even asked the question about, well, what's the value in doing this? Why are we doing this? And if our stakeholders knew why we were doing it and how much pain it was going to be, we would have probably got more done as we went. Okay. So this is the first kind of lessons learned in the top-down project versus a project the team has identified for themselves. But everything was just a chore. From the wider team, like I was saying, there was no buy-in. When I'd worked on other Kubernetes migrations, there's always somebody who's like really keen. They spend their weekends looking at new systems. They got great ideas for tools to bring in, or become experts in particular parts. But when the organisation just says, "Here's what you're doing," everyone kind of looks at the team who've made that decision for the way forward. And then, it's just a case of like jumping through the hoops of the team. Well, we want to deploy, so we better go along with all this. And everything is a bit grindy. I kind of put in here, like one of the things we learned along the way is when we were demoing our features, rather than just showing people about, oh, this is what we were done, we kind of had to go into this is what we've done, and here's why it's really important and going to really change the game for you. And kind of not just showing like kind of done features like Kubernetes deployment, but saying, why the kind of things, we're going to help in there. Kind of that was some of the things that started to get our business stakeholders going, oh, maybe this is not the painful project that we thought it was, and it's going to pay out at the end. One of the other things about this top-down project is there's just less control. One of the things we suffered from is, our big bosses on high had decided about this strategy. Teams were working on it. Few things have been migrated across, and then they think everything's done. But actually, there was still loads of stuff in the platform that wasn't done. And what this is kind of showing is like just the areas of control. Like when teams pick a project themselves, they've got this whole wide circle where the team's in control of what can happen there. They can make decisions with product owners about what's in and not in scope, and quite a lot can be done. But when you get this kind of thing, you've just been told to do something, that area that you're in control of, it gets smaller and smaller. You see that the green circles are the areas you can influence, and the blue, the kind of things that just happen to the team that you have to suck up. And this is kind of just our experience of like the different projects where we decided we've got kind of quite a lot of control and not much happens to us. But yeah, this top-down project, a lot more things that happen that don't really have any influence over. And then kind of learning to ask these kind of questions. Well, who's really going to champion this for us? We had sometimes that was the business people who really wanted the things delivered. They could take their business case back to organizations and get things moved for us. Sometimes it was just the technical people who wanted to prove their new toy worked, kind of knowing who those engineers who could help us in different places were. And we kind of spent the time kind of, picking our way through the organization and trying to slowly learning, well, where is the best thing to make this request? And also having to be much more proactive than we normally would. We'd be used to kind of in a sprint, being able to say, oh, we can do this work and get it done. But when we've had this top-down approach without the control of being able to make the decisions about what we had to do when, it's a much more like kind of looking forward a few sprints, we're kind of working out what the blockers were going to be and chasing those down to help the team deliver as we went. And looking back on it as well, the funny thing that happened, all of a sudden, just the normal stakeholder relationships kind of swapped around. All of a sudden, because the big IT organization said, oh, we need to do this Kubernetes, and I was taking up so much of the project's time, stakeholder management, unknown to me, became my responsibility. You get project managers, customers, all suddenly looking at the techie people to go, what's going on? So I think that this was a surprise, and it kind of, it just crept off without noticing. And looking back on it, this is, kind of thing I learned. It's like understanding what the different stakeholders are, and kind of learning from your product owner what they do, and kind of replicating it when you become the techie person, kind of basically owning that product. So who are the people who you just need to keep happy? And some of those, the boss managed by PowerPoint, they just need to see the green tick on the project plan. But who are the people who are like more day-to-day on the project, who really have to keep in close to what the blockers are, where they can help, what the statuses are. And then think about the dev team and who people are going to be impacted. Don't really have much power, but they still kind of need to know what's going on. Those kind of stakeholder management that kind of sneaks into the job the tech team are doing was a bit of a surprise, and a kind of a thing to look out for. The other thing that I discovered about top-down projects is changing the scope is hard. Like some of the other projects we do, when you're talking with a business team, you can say, like, how much is this really worth? You talk about the 80-20. If we could do this much of that feature, would it still be worthwhile? Well, we've been told, something like this, just migrate to Kubernetes, and they want the whole thing. You just have to do the whole thing. And this triangle is like project management triangle. In the case of this kind of thing, the only really thing that's going to change is time. So this kind of top-down, working against the organization to get our job done, just took much longer than we ever thought it would do, because that was the only thing we could change, like the when things were going to happen in there. So it's just, if you're going to go on this journey, it's expecting that it's going to take longer than you would ever think. That's just that. This is a bit more about what we had to work with. That question at the beginning was like, what would you rather have? Kubernetes infrastructure the dev team looked after, or borrow one from the organization? We were I think on reflection, lucky that we had the organization choice. It helped us probably on average just about as much as it hurt us. Like I say, there wasn't a fully mature solution when we were there. We were one of the first big projects that moved across to it. So there's still a lot of things that were in development, and we were trying to match our development stage with theirs. But the vision that they had, that we signed up for at the beginning, was awesome. A lot of self-service work. So there's a portal where you can sign up for access, create all your namespaces, APIs that they created around deployments. Multi-cloud was designed in at the beginning to make that largely transparent to the development team where you were deployed. So we've got a mixture of deployments, internal, we hosted, some on AWS. And really, as we do those deployments, there's nothing much that changes for us. It's really in the setup phase and getting some of the firewall stuff set up where we notice the difference between the cloud providers. So they did a great job. This is the process that we were working to. And as we went through each stage of this process, we kind of learned something new. So we had, the process, create a container, push it up to their repository, then to process a request, a vulnerability scan using Sysdig. You get the results back. If they pass, that's fine, you can deploy it. And then the next part of their process, create the namespace, that's like a one-time thing, look after the Helm chart, and then to call the deployment API to make it all happen. That's the kind of development process we went through and learned stuff at each phase. The first thing we learned is our container wasn't quite as ready for production as we thought it was. We've been building Docker containers, using them in our CI/CD pipeline. So we thought that process, that is going to be the easiest thing to do. And then we discovered that we'd hard-coded all the configuration for our CI/CD server. And actually, as we move through the environments, there are about 300 different things that change in the application depending on where you're going to deploy it. Some of this was just because developers have made just about everything you could make configuration. So if you want to change the color of the ticks we use in the UI, you can do that with a property. Yeah, but that was hard work. Some of the using a platform from the organization, we were a bit constrained about what tools we could use. So we used different config management tools on different projects, but none of those were approved options for us. So we had to do everything in the container. We found this awesome project Sigil from Glider Labs, which uses like Go templating, and that saved our bacon, kind of passive environment variables, used the templates, create our magic config files, and we were all back on track. Security scanning was another pain. Just to give you a bit of context about for the Java devs in the room, the sister app to the app that we're talking about here still uses Java Web Start. Don't know if anyone's ever used that for real. It's something I'd only ever read about until I saw it in this project. And this workflow app uses just about every Java library ever created. I think if Nexus Central goes down, just ask us. We've probably got a copy of the jar on our machine. And so going through the first vulnerability scan phase was interesting. We spent a lot of time kind of submitting our container image, getting the results back, seeing where we failed, doing some updates, seeing we failed again. And stupidly, we kind of use this as like a one-off exercise. We did some stuff, deployed it, everything was fine in QA for a while. Project carried on, then we built some more features, tried to deploy it again, and the scan failed. So pretty soon we learned that automation really should have been our first thing. Built the image scan into our just general ICD, so now every commit that goes to development gets scanned, so we kind of get these failures before they stop us deploying. And yeah, just adding to that the baseline. A little kind of other lesson learned that we got here was spent a lot of time looking at the base image that we used for our application. We had to change it 2 or 3 times as we discovered different base images that were published by the platform team got updated at different intervals. And we had to make sure we found the base image that actually stayed in sync with when the scan was updated, because otherwise we just kept getting blocked with things that were kind of, on that OS level rather than our application. So that's a little tip. Make sure your base image, if you're using one, stays in sync with the cycle of the scanner. And here's a kind of, the next thing when we try to deploy, this is where we kind of really discovered that the development teams' view of the world and the platform teams' view of the world were quite different. Previously, I think most of us have just been deployed on public clouds. So you kind of got this idea, the cloud's there, you can make it grow as much as you like. And then we discovered, no, not an internal Kubernetes cluster, you can't. They actually have resource constraints. And this is where we had that kind of difference in the kind of assumptions. The team who were building this platform team, they thought they were building a platform for little lightweight node microservices. We thought they were building a platform for big chunky enterprise Java apps like us. So we had a little crash and burn moment when we discovered we used up all their space all the time. So we had to scale down our environments in Dev and QA so we could actually deploy and get our testers testing. And that kind of comes back to bite us later in the story. I think another place where we had a lot of problems, we had this lessons learned moment was every time we deployed, we'd have some kind of, to a new environment, we'd have a connectivity problem. One of the pains about kind of having a central team is that none of the teams we're connecting to would take ownership for a problem. If there was any problem connecting when you were on this Kubernetes platform, it was always a problem for the Kubernetes team. Even if you couldn't talk to the database or whatever, it's definitely something to do with Kubernetes. It's not affect our systems down. So eventually we kind of went back and we added in health checks to check all our dependencies and to save us, as we deploy the new environments as well, we've kind of built a new mode into our system which is basically the pro mode. So we could deploy it with a feature switch. So none of the public facing app would work, but we could use all our health checks to check that the environment was built out properly. One of the problems that came to us because we'd scaled down in some of our environments is when we went to new environments and scaled up, we discovered none of our SSO or stateful kind of parts of the application would work anymore. So because we've been working on those single instances in these lower environments, going to multiple instances, bad news. We had users who were losing their data all over the place. Eventually, we kind of worked out why, updated the ingest controller, made some little changes to the SSO cookies, and got there. And that's kind of it. The last thing was just no DR environment. So we naively just assumed that because we were in the cloud, that DR would be like, a day one thing. Discovered no, the DR wasn't a day one thing. But in the organization we were in, DR is like a gate to production. If you don't have a DR strategy, you're not going live, and this made our stakeholders cry. Every time we mentioned DR in a meeting, you could see them switching off Zoom cameras. And eventually we got this where it was like just one of these little assumptions, like dev team, we kind of assumed the platform team would have DR down and sorted out, but the platform team were like, well, no one's going to need DR. Everything works. So yeah, that was just one of those little assumptions that we missed. Yeah, I think this is like one of the things about this project was going live was a massive anticlimax. We went live and it all worked, which was good, but also disappointing. We didn't really notice. And these are the things that we kind of did notice, though, that because we were one of the first things that moved across, we're still using kind of non-cloud kind of monitoring techniques for our apps. So we've got a bunch of kind of essentially pingdom kind of things, like checking is your server up. And when the containers are just restarting as nodes are going up and down and getting recreated, we would get loads of call outs. So your prod server's down. It's like, well, it's been down for a minute in the middle of the night. Is it really down? But we'd still have to do all the kind of cleanup stuff. So I think that's like, how does that work in there? And that's in the alerting strategies. That's there. And one of the other things that kind of in the beginning was fine, but as the project teams kind of been rolling off and going to other projects, this is where we kind of discovered the other pain. Like, how do you upskill the whole team? Like, we went with the project team doing a lot of work to make it happen pretty quickly. And like I said, as those people are gone, but the rest of the team are like, oh, what happened to all those guys who know about Kubernetes? Why am I left doing this? So I think that's really where our sticking point is. Like, how does that team, like I said, kind of think about DevOps as basically something that happens to clean up or to make things happen, take that on going forward. These are a little my tips. I think some of the stuff that we discovered is like, well, as we went along, things that we just took for granted that we thought would be obvious, like being able to connect to NAS drives or use FTP, have the DR system, they weren't there. I think if we thought about them at the beginning, gone, oh, have we got all the things we actually need to run our platform? This would get there. One of the other things we kind of noticed we were doing is, like, as we kind of had to change things to go along, we're like, oh, we should really fix this. And then we had to remember, no, we really have to go live on the day we said we'd go live. So we had to kind of fight that scope group all the time and go, like, even though we know this is like worse than we thought it was, or we found this new problem, let's capture it, put it on the backlog, fix it when we really should do, and stop that scope group. I think, just being ready to go live. I think one of the problems about being the first team to go there is, like I was saying, the whole monitoring alerting piece. We had ambitions for what we could do, never quite got to it, like delivering the business features we were doing alongside this migration, kind of trumped all this, but it is the thing that's caused us the most pain since we've gone live, just the understanding that has the system gone down just because it's a node restarting, or when has it really gone down? What we're discovering more and more is it's our back-end systems that break more often than us. But they don't really believe us when we tell them they've gone down. So it's like, how can we build those checks in? Instead of the alert coming to us, we can redirect it straight to those back-end teams for the ticket, rather than us getting the alert, manually doing some troubleshooting, and then sending it on. More lessons learned. This was the biggest surprise of this project was I've worked for a lot of startups and consultancy over my career. And I just have this naive view that, you know, IT guys are like the early adopters. If there's a gadget, we buy it. If there's a new thing, we're there. And I discovered actually there's a whole organization of people who are not early adopters, who are quite happy to be laggards and kind of go with what they know. And that was hard work to change that. It's kind of like, this is the hardest part of this project. We're like, well, how do we get change going? Getting that vision about, you know, what we could deliver. People who are used to a quarter release, how do you even get them to imagine that end of sprint production release is really possible? And it's like, they're like, no. And I feel like that guy from Life on Mars, where he goes back in time and he's seen all these modern release methods, and everyone just laughs at him. That was kind of me there. And so these are all the kind of things, like, you know, trying to create the roadmaps and go, well, this is where we want to be, share that vision about, well, we had this problem, but if we did this, that would fix it. But yeah, that was harder work, and I think took it for granted that people were just like, wanted to change and try new things, but that wasn't true. It's kind of a similar lines. It's like the myth of the T-shaped developer. Like I said at the beginning, I'm a big Agile fan, and if you read any Agile book, probably on page 3, it's like, oh yeah, teams are full of T-shaped developers, happy to solve all kinds of problems. Well, that's not quite as true. And that, I guess, is shaped by the culture we're in. We work in a big organization, these big specialist teams, and that kind of changes that. It's like everything is somebody else's job, and trying to get that changed. Again, it kind of feeds into this, like, well, who should do the deployments? Who should look after the CI/CD pipeline and make things go to production? And how do you get the development team who they've never seen it happen before get into there? And some of that is like just talking about it. Some of that's kind of showing that it can be done, pushing people out of their comfort zones, giving people kind of different tasks in the stack to work on to help get this. It's something we're still working on. Again, you know, kind of assume that developers want to be that way, and then discover that no, there's quite a lot of developers who are quite happy staying just in the development lane. I think this is like a lesson learned in ownership. But at the beginning of the project, loads of people were like, "Oh yeah, can you write us up a wiki page about how this works and or how I do that?" We discovered, like, as we did that, the people who wrote the wiki pages were the only people who ever read them. The rest of the team were like, okay, there's a wiki page that tells me how to do that, but could you just do it today because I'm pretty busy? And so more and more we went to writing scripts to do things. This is like everything from things like vulnerability reports. There was a wiki page telling people how to interpret them and what they had to do. And then, as we discovered they never did them and always asked somebody who worked on that piece to do them, we kind of wrote a script that said, okay, run this script, and it tells you the answer of what you need to do next. Same with all kinds of things we did on there. And just, maybe the people say they want wikis, but really they want automation. And that's, again, this is like a hard thing, like an assumption, you know, kind of after that, you kind of assume that everyone wants to build a system and see it work. Actually, lots of people just want an easy life and make it happen. If you don't take ownership as the tech team of the overall solution, that's easy on one way. I think the last thing, like, as I'm kind of prepared for this talk, it's like, you know, it's a project that was painful, but looking back on it, there's loads I learned that are going to be useful for future projects. So I think that's just a kind of final kind of lesson learned. If you do something like this, have a think about it. Invest some time, write a blog post, or come do a cloud native talk, because you've learned so much more kind of looking back on it, thinking about it, what was important, what could you share. Definitely worthwhile. And then it's time for questions.
I'm going to take over sharing screen.
Yeah.
We're going to use that same polling service to get questions with David. So looks like we've got a few already. So that was oyshow.com/p. First question is, what's the best approach to make a container image of a Java app which is already manually configured on AWS?
Straight in there. Ooh. Yeah, I mean, like I say, what we did was just try and think about that. What is it you're configuring? I guess that's the thing. Who asked this question? I think in the room, because it'd be probably useful to have a bit more context. But I think it's just trying to, think about what you can configure, what will make it run. I think this is the journey we had. Like what made it run locally in our tests, to what made it on production, and looking at those differences and kind of trying to extract them out so we could pass it in, whether that was from our Jenkins build or whether that was for real on the deployment. It's what we're looking at that. So I think that's the kind of approach. What is it you need to configure, and how can you make it that kind of immutable image that goes to all the environments you care about? Hopefully that's answered, but feel free to follow up. So did you consider Rust? Like one of the big things I guess I missed out of the context thing is our application is deployed in 4 countries currently. And so we were going to country 4, and that's where we had the block. So it was on 3 Tomcat services that other teams were kind of looking after the roadmap for those. So it's been a process of kind of, as we've gone to Kubernetes and kind of putting that out as the platform and changing the model of the team to agile, kind of those bigger technical kind of refactorings are kind of, still on the roadmap as we consolidate that. So consider rewriting, but it's always it's not going to happen today. What about Jib? Oh, how about Jib? It's probably similar to the Rust thing. I think it's that kind of, what we're trying to do is, it's kind of like a lift and shift without disrupting anything else. That was the kind of constraint we were working in. I'm kind of going, okay. What alerting did you use for downtime? We're like hooked into Datadog. So I think that's not really alerting for us. Like I was saying, we're still using this kind of alert side legacy thing, because in the organization as a whole, we're probably talking about, 2% of the real estate is Kubernetes, the rest is old school. So some things haven't quite moved into the world of cloud. So in terms of latency and resource use, we can go into Datadog and see, but in terms of actually finding out about them, we're kind of still stuck in that kind of call an endpoint, get some results, make a decision, let us know. I'm just laughing at where did you find a team of developers. That was the biggest surprise to me on this whole project. There are lots of them. It is a surprise. I think if you come to meetups like this, you'd be surprised about that. In terms of measuring technical debt, we use SonarQube and we're kind of tracking what's happening in there.
The top one.
The top one, yes. I think we did have senior sponsorship, but no, it didn't help. It kind of helps, but it doesn't. It's back to that stakeholder thing I had. There's lots of eyeballs on it, and people who want to make it successful for all kinds of different reasons. So you've got that whole kind of people in the platform team who've told everyone their project's ready, right? They've said, yeah, we've nailed this. We've got production clusters. We've got things deployed on it. And then you discover the things they got deployed on it are all the tools that the platform team use themselves. So we come along as probably like the second app on there, and the first app that really does a lot of business value. And then we go, well, it's kind of done, but it hasn't got DR, which obviously you don't need for the internal dev tools, but you do need for production data. So that senior sponsorship was a bit patchy. Sometimes it helps. It was really about, like I was saying back, it's like finding the right person to ask the right question. So sometimes when we needed stuff moved on project roadmaps, whether people knew it was technically possible, that was getting the business people to restate their business case and get ahead of other people's. And yeah, sometimes just about finding the right architects to kind of find a corner for a decision. We're just using the standard JVM, and again, that was kind of linked back to we had to build this in a way that didn't disturb the existing stuff. And how badly out was, yeah, I guess. Yeah, the senior leadership of Kubernetes is probably not badly out. I think what is out is like, it's one thing to move your application to Kubernetes, but they see this whole thing as a transformation of like how you change the whole engineering culture of the organization. Yeah, so they knew what Kubernetes was all about, but like I say, they built it for these, they've got this vision of being able to drive microservices really quickly to deploy the whole thing. So as somebody who, his application started like years ago, that was the way the mismatch really was. And then we got, had you ever let anyone, did you ever? No, I mean, much as I'd like to let people go because they didn't read the wikis, I slowly worked out that, the wiki maybe wasn't the best place. Just easier to write a script and you're automating document. I mean, most things, in terms of the automation question, I think that's where we kind of saw just much more value. Especially when you answer the same questions of the team, the 10th time you go, oh, why didn't I just write a script in the first place? That was there. There's still stuff on the wiki that it's not the how-to in the troubleshooting place and kind of the edge cases. Anything that's off the bottom of the screen? I think I can think with so I think we got refactoring the app into microservices. That is in the world of yes, we'd love to. And we've got a couple, but for us, it is about getting onto that common platform. So we're still in the state where we've got half the estate is on Tomcat, half the estate is in Kubernetes because it's like a country by country implementation. And I think that kind of true microservices is once you've moved everything into Kubernetes, we can start doing some more intelligent refactoring there.
Okay.
Cool.
I think we're good. Another round of applause, please, for Dick. And good job on asking all of those questions. That was quite impressive. All right, so now we're going to hand over to Jacob. And Jacob, feel free to share your screen and pick up whenever you're ready.
Great. Yeah. Right. Hopefully everything has appeared.
Yep, that's good.
Awesome. Cool. Okay. Well, hi, everybody. Thanks for having me. I apologize for not being able to be there in person. I had some family stuff come up that meant I couldn't spend a night in London. But yeah, I'm glad to be here now. So click next. My name is Jacob Tomlinson. I'm a senior software engineer at NVIDIA. I spend a lot of time working on cloud things, but I'm actually like, my job is like a library software engineer, right? I build Python libraries, particularly for doing all sorts of stuff. A lot of that is around distributed computing. I work a lot in the like data science, traditional science kind of ecosystem. I work on projects like Dask and Jupyter and those kind of things. So I spend a lot of time thinking about like, how do we package up environments that folks might use, software environments, and get them in some kind of deployed distributed way. And there's like a million different ways of doing this. But Kubernetes comes up over and over and over. So I've spent a whole ton of time thinking about that. So one of the things that is kind of involved in my job is we maintain a bunch of Docker images. So I work on a couple of projects. One is Dask, one is Rapids. They're both like Dask is a Python library for doing distributed computing. Rapids is like a collection of Python libraries for doing GPU accelerated data science type stuff. But you tend to install them like in some kind of Python environment. And we often package those up as Docker images, right? Just like as the projects, we package those up, but also then for specific like uses, for specific systems, we'll create like an opinionated stack of that software with extra things installed and application code and all that kind of stuff. But we spend a ton of time building Docker images. And one of the challenges of that is we have to try and make the like official images that we provide in the projects pretty generic, pretty small and lightweight, and we try and target them at specific places they're going to be used. So, you could pull them onto your local machine and just do Docker run or whatever and use your container image that way. But we also try and target the kind of environments folks are going to be working in. Maybe you're using AWS, you want to use SageMaker. Maybe you're using Azure and you want to use Azure ML. Maybe you're using Kubeflow if you're on Kubernetes. There's a whole bunch of different places where we're running stuff. We have like internal HPC type platforms that we use these images on. There's like a wide scope for these images. And so I occasionally make contributions to these images. We make a change, and sometimes I do that with a specific target in mind. So I was working on the Rapids image a few months ago, and we wanted to make sure that the Rapids image would work perfectly on Kubeflow. So for those of you who don't know Kubeflow, it's like a machine learning MLOps type platform that you can install onto Kubernetes. It's very Kubernetes native. And one of the things it has is a notebook service. So it's like an interactive service where you can launch Jupyter or VS Code or whatever your kind of preferred environment is. And you kind of do some interactive data science work there. And that works by just choosing which Docker image you're going to use for launching the application. And so we were like, oh, it'd be great if we could just drop the Rapids Docker image in. The Rapids Docker images start Jupyter anyway, and they just have all the GPU stuff installed. So we should just make sure that this plays nicely with Kubeflow. I came in and made a change to that image. There was just a couple of assumptions that Kubeflow made. And in doing that, I changed the Rapids image and then got a bunch of emails from somebody else within NVIDIA working on some internal platform saying the images have changed and now our whole platform is like not working. We can't launch the Rapids images. What has changed? What has happened? And we kind of had to unpick. It was just to do with which process was process ID 1. And it was just some weird little assumption that had been made in the building of those two systems and we caused a regression basically in making that change. And so like the Python developer in me was like, okay, I'm going to fix the regression and I'm going to add a PyTest test to stop this from happening again. And then I thought, oh, wait, how do I add tests for my container images? How do I avoid these regressions? Did a bunch of research, didn't come up with anything that I found particularly compelling in terms of tooling. So I ended up kind of going off on a nice yak shaving tangent and building Container Canary. So the intent of this talk is kind of not talk about anything particularly NVIDIA specific, but just talk about Container Canary and what it is and what it does and how we're using it in the hopes that other people will start using it too. So the main piece of Container Canary is a command line utility that you can use to validate your Docker image against your assumptions. So you write some kind of specification that describes what the interface, what the API, what the, like, however you want to describe it, like what the expectations of that image are, you write that out in some kind of programmatic way, and then you use the command line tool to test your image against it. So it's really great for running things in CI. We have like, GitHub Actions set up for building these public images. We have internal CI for internal images. And really, I want to be able to just add an extra step to the end of my container builds that just pulls in Canary, has a manifest with the expectation of that container, and will just validate yes or no, give me a pass fail. In the same way I'd write unit tests for code, I wanted the same thing for my container images. So to like dive into this specific example to show you what I'm talking about, the change that we had to make to Kubeflow was around which process started up when the container started. And there was also one assumption about what the user ID was. And so these things were like a little out of sync. If you go to the Kubeflow website and have a look at like which images can I use with Kubeflow in the notebook service, it has a list of their official images, but then there's like a little chunk at the bottom here that just says, if you're creating your own custom images, here are the things you need to do. And often you see this come up in all sorts of different compute platforms. But in a lot of these, they say, we have some base images, you should use those base images. And then you can kind of have a bit of assurance that you're going to comply with our expectations and you install your own stuff on top. But if any of you have been through kind of security and accreditation of using random Docker images from the internet on some kind of secured system, that often just doesn't fly. You just can't use random images. Many organizations will have like an internal vetted and tested image that you have to build on top of, or at least you have to go through some kind of internal registry so that you can be doing vulnerability checking against your images periodically. So you can't just go and grab the off-the-shelf images. So what they kind of give you as a secondary thing here is, here's a bullet point list of the things that we expect, right? Your container, when you start it, will expose an HTTP service on port 8888. If you set the MB prefix environment variable, that sets the kind of base URL that will be prefixed on wherever this application gets reverse proxied within Kubeflow. Kubeflow is going to use iframes, so you have to make sure the application sets the right headers. It's expecting the right username because it's going to mount a volume in that's going to have the expected permissions, and it's going to mount it to a certain place, right? Like there's all these kind of expectations, and so you have to make sure that your container image meets this. And I just gone to this page and made it meet these expectations without necessarily considering how these expectations meet up with all the other expectations of all the other systems and whether they're even documented or not. So within Container Canary, instead of having a bullet point list like this, we have a container manifest, which you can see in the left here. And now I'll kind of go into a little bit more detail into this in a minute, but you write out in some YAML. If you're used to Kubernetes, this will look very familiar to you. This isn't actually like Kubernetes specific, but it borrows from the Kubernetes way of writing configurations, and it actually borrows from some of the Kubernetes API as well. So you write out these expectations kind of as checks in code, something you can check into version control, something that you can test against. And then on the command line, you do canary validate. You give it the path to the file or the URL of the file that you're validating against. You give it the container name, and it'll just run through a set of checks, just like running a test suite, and then give you a pass-fail at the end. So we use this in Rapids now as part of our CI. We test against Kubeflow, we test against Binder, we test against Dask, just to make sure that our images are going to slot into all of these various places. It also means that we can kind of more explicitly say, we do support this and we don't support that. And sometimes somebody will come along and say, oh, can you use your images on, I don't know, Google Cloud Vertex AI? Can you come and drop your images into our platform? And we can then come in and say, right, let's write a manifest and run the tests. And sometimes we find that there's like conflicting things, right? Some platforms have expectations that are just not compatible with another one. Like if you had a specific user ID in mind, like, and they're different between two platforms, you would have to build two images with two different user IDs. And that's just how it is. But it allows us to make more kind of backed up and reasoned decisions about what container images will support which platforms. So installing Container Canary, it's written in Go. You can find it on GitHub. Installing it is just a case of pulling down the binary, making it executable, checking the checksum, and then you can use it on the command line. So I'm going to attempt to do a live demo. Often these go wrong, but let's have a go at doing some kind of demo. Hopefully you can still see, I'm just logged into my Linux machine here. So if I just do Canary version, you can see I've got whatever the latest release is, 0.2.1, that was built a little while ago. There might actually be another release since then. But anyway, this is like a reasonably up-to-date version of Canary. And I could do something like going and grabbing a manifest. Now, if you head to Container Canary on GitHub, let me make this a little bit bigger. If you head to Container Canary on GitHub, there is this like examples folder, which has some manifests that you can have a look at. Now, all of these manifests are kind of based on the spec here that we've got in the README. So if you have a look at the like validator reference, you can see you set a bunch of metadata at the top. This kind of looks familiar to Kubernetes folks, hopefully, that you set your API version and the object kind. You set some metadata like name and description and documentation. This ideally is the link to that page with the bullet point list on, so that if you want to keep those things up to date, it's a little easier. And then we have to set some runtime options.
So it's just hard to see.
Yeah, I can make that much bigger. Is that better?
Yeah, it's better.
Cool, perfect, awesome. So in the runtime options, you then need to set the things that would be, if you're running on your local machine, it would be passed to Docker run. If it was in Kubernetes, it'd be whatever the container spec is. These are the kind of things that the platform is expecting to do to the container. So is it going to set some environment variables? Is it going to expose some ports with a service or host mapping or something? And is it going to mount any volumes to any location? So for Kubeflow, there's a few things that were kind of listed in that bullet point list about what environment variables would be set, what ports would be exposed, and that kind of thing. So you capture all of that, and then you list the command. So a lot of platforms will some of them will like start the container just with whatever the command is set, but some of them will just say, no, I'm going to run this command. This is my, I'm using something that's a little opinionated. So you can also set the command that is expected to be run in the container. So once you've kind of set up what that environment will look like, you then have your list of checks. So under the checks API, you have just a list. Each one has a name and a description, and then each one has a probe. And for those of you that have done any kind of liveness probes, readiness probes, that kind of stuff in Kubernetes. This is that exact API just kind of lifted in here. It's one of the reasons I wrote this in Go is I can just import the code straight in. So we have exec, so you could just run commands inside the container to make sure that it's happy. So if you want to check what the user ID is, you could just write a little snippet in there and exec that in. You can do the HTTP GET in the same way that you can in Kubernetes to make sure that a service has come up, it's got the expected headers, it's got the expected content, that kind of thing. Or you can just prod a TCP socket to make sure there is a thing on a socket. And all of this supports with a kind of standard delay and timeout and thresholds and all those kind of things. So it will start the container and then prod it for however long you've configured the timeout. I think the default timeout is 30 seconds. It will just keep prodding the TCP endpoints and things. So once you've written all of that, you'll have a manifest. So if I go back into the examples and have a look at the Kubeflow one specifically, that bullet point list that was on the Kubeflow website has kind of been captured here, right? They're going to set this environment variable. They're going to expose this port. They're going to mount this volume. And then each of these checks, they've said, your username has to be Jovian, right? This is just a Jupyter thing. Jovian is a citizen of Jupyter. It's slightly whimsical, but you have to have this username. The user ID has to be 1000. The home directory has to be the specific location. It has to expose something on port 8888. It has to honor the prefix path, and it has to set these right headers. These are all the things in that list. We've now captured them programmatically here. So then if I come back to my terminal, I can validate that manifest, but let's validate that against a container we know doesn't work. So let's just use Nginx, right? The Nginx container does not meet any of these requirements. So if I do canary validate, it'll pull that image down.
Sorry, Jacob, could you make this a bit bigger?
Yeah, is that better?
Keep going.
That's
okay. That's good. Thank you.
That's probably as big as it will go before the next line might run off, but that's fine. Yeah, so I can run canary validate. I just give it the URL of this manifest, or this could be the local path if it's in your local environment, and then you give it the container name, right? So here with Nginx, I keep just running this, and none of these things are true, right? The user ID is not right, the home directory is not right, it didn't run something on port 8888. This is just not a valid container for Kubeflow. And this is great, we can test this, we can be confident in this. Now on the Kubeflow website, like I said, they have a list of these are our official images, and you can use these as base images. So let's test one of those. So here we have one, they've got them all in ECR. They just have one of their kind of official images. This is the Jupyter SciPy image that is, they say is guaranteed to work with Kubeflow. So let's make sure that that's true. We run canary validate with our manifest, runs all of our tests, and they will pass. So that's kind of roughly Container Canary, right? You can come in, you can write tests, you can make sure your container does what you expect it to do. And you can also be confident then that other folks can come in, they can make changes to the container, and your test will still pass. I think in this kind of world of infrastructure as code, there's still some missing pieces in terms of kind of what software developers are used to doing. So let's go back to my slides quickly. So what's next for Container Canary, right? Like this exists, this works. It's up on the NVIDIA GitHub. You can go and find it and use it. We're using it for a whole bunch of projects. There's more work we want to do. It's kind of, I would say it's like complete. You can write all the tests. It meets the Kubernetes probes API. You can go and use it. I'm not guaranteeing it's bug-free because nothing ever is, but it's kind of ready, and I'm excited for people to start using it. But there's also a whole bunch of other things that I want to do next and want to see happening next. So one of the things that I found interesting with this is I used a Go library called Bubble Tea, which is from a nice group called Charm, and they're building some really cool tools for building nice terminal applications in Go. So if you write Go and do any like terminal application stuff in Go, this is a really nice tool to use. It's how I got like the nice colors and progress bars and all those kind of things. That's great. I want to keep improving that, make it like a nicer experience, make sure it works on kind of more stripped down terminals and things. Maybe provide a bit more output to the user and a bit more control to the user over what's running. The other thing that I want to do, which I haven't kind of come around to yet, is actually fulfilling the name Container Canary. You may be wondering why I named it Container Canary. One of the initial ideas was I would run the tests inside the container. And at the moment, I'm just using the Kubernetes probes API to prod it from the outside like you would on Kubernetes. But there's a lot of things that it might be easier to have something in the container, an executable that can kind of feel around from the inside and see, what is here. And so one of the intentions of that is that the Canary binary can be mounted into the container. Obviously, like that's on Linux only. If you were on Mac or Windows, it would have to go and either have to bundle the Linux binary or fetch it from somewhere. But you would mount the Canary binary into the container, and then the kind of outside Canary that you're running the tests with would use exec to speak to the inside Canary, and then it could kind of prod around and do things. So it would allow us to write more high-level tests. Instead of you having to write little bash or shell snippets to do various things with exec, you could have some more specific things. We could just have a user ID probe, right, that Canary would use, and the internal binary would check that for you. So having something there inside the container will just make it easier to write these tests. So like in probably version 1 of Canary, whenever we build that, it'll have this kind of idea of mounting Canary inside. I'm also keen to just keep building more examples. We built the examples that we're using for the workflows that we have right now, but there's a lot more platforms that we want to get on. We would really like to have like that examples folder in the Canary repo to just be like a bunch of common platforms where folks are used to bringing containers to and that have expectations. But also, it would be great to just have more examples and things for folks to be able to just go and copy and paste and get code snippets from there. So we're going to keep adding example manifests. But really what I want to see in the future is, instead of going to a documentation page like Kubeflow and see a bullet point list of stuff, I want to see a bullet point list and an instruction saying, here's a manifest, you can use Canary to double check this. So it would be really great for other projects to start using Canary, writing their own manifests, and kind of sharing their expectations with their users in a programmatic way instead of in written language. So that's kind of why I'm coming to groups like this and saying, please use this. I'd be really happy if you use this, and I'd be really happy if you told everybody else about it. So how could you help next? Go find this on GitHub, go and hit the star button. That would like make life easier in terms of me telling stuff about it, telling people about it, but also start writing these tests. Put your tests on GitHub if you can, and just generally, share the goodness about Container Canary. So yeah, that's it from me. I hope that was interesting, and thank you all very much.
Jacob, I'm going to take over sharing the screen so I can put up some questions. And looks like we've got a couple already, so you can read it and just take it from here.
Perfect. So yeah, okay, I'll go top to bottom then. So does exec not get all of the functionality you need to run things inside the container? Yes, it does. I think the worry maybe is that if we would need to do like shell templating, basically. If we wanted to make some configurable options, we would have to write little snippets of shell code that we would use exec to run. And then we'd have to be like templating into that. And I already maintain too many projects that do some kind of templating like that. That makes me sad. I'd much rather have some kind of API I control, right? Maybe I pass a JSON object back and forth between the inner and outer binaries, and have the binary kind of do the stuff in Go in a way that I can test and control and be a bit more sure of, rather than relying on exec in that way. Okay, let's go next. How many canaries died in the making of Container Canary? Yeah, none. I don't know if I've even seen a canary in real life, so next would be, can some of those checks be performed by static analysis directly in analyzing the Docker file? Yeah, absolutely, they could. But not all of them. So like, I have to start the container in order to test some things. And so like, I might as well test all the things in that way. But yeah, that's definitely like another step that we could add in the future. Do I have any spare 3080s lying around? As far as I know, things are a bit more chilled in terms of buying stuff. So hopefully you can buy stuff these days, but who knows? Have you considered using Container Canary as an admission controller? That's really interesting. I hadn't, but that's a really good idea. Yeah, no, I like that. That sounds really neat. We're looking at using it in some applications kind of as a step where a user comes in and they provide their own image and we run Container Canary check before we do it. But we were thinking about doing that at like the application level. But doing it as an admission controller would be a really interesting place to put it. Yeah, so thanks. Yeah, I think that's all the questions. So thank you all so much.
Anyone for any more? Okay, thank you so much. Another round of applause, please, for Jacob.
To answer that last question that just popped up, I would say Nintendo Switch because it's got an NVIDIA chip inside it.
Okay. All right. That is it from us for tonight. Thank you so much for coming to Cloud Native London. Hope you enjoyed yourself tonight. If there's any pizza or beer and stuff, like please take a bit more with you on your way out. I think we're going to go to the pub around the corner, which I forget the name of. Turn and Bundle? Something like that? Tank and Paddle. Close enough. Tank and Paddle. So it's 2 minutes around the corner. Please feel free to come and join us and hang out for a little bit longer. Otherwise, I will see you on the first Wednesday of the next month. Take care. Have a good night. Bye.